Okay, so our original equation is f of x equals 12x squared plus 9 over 3x squared minus 3. So first what you're going to want to do is factor it. So we can do 3 times 4x squared plus 3 over 3 times x plus 1 and x minus 1. And then to find the wholes, you want to see if there's any common factors, and in this equation there isn't, so the wholes don't exist. Then for the vertical asymptote, you said each part of the denominator equal to 0, and we know 3 can't equal 0, so when you do x plus 1 equals 0, you get x equals negative 1. And then when you set x minus 1 equals 0, you get x equals 1. And then to find the x-intercepts, you set the numerator equal to 0. So 3, again, can't equal to 0. And you're going to do 4x squared plus 3 equals 0. Minus 3. But the thing with this is that since there's a negative 3, we can tell from now that we're going to end up with an imaginary number when we have to do the square root of it, so x-intercepts don't exist. And then to find the y-intercepts, you want to plug in 0 for the x's into the original equation, so 12 times 0 squared plus 9 over 3 times 0 squared minus 3. So then these are all going to equal to 0, and you're left with 9 over negative 3, which is the same thing as negative 3. So your y-intercept would be 0, negative 3. And then for the end behavior, that's the horizontal or slant asymptote. So you want to look at the degrees on the x's, and since they're equal, you want to divide the coefficients, so the 12 and 3, and 12 divided by 3 is 4. So y equals 4. And then for the limit notation, what you want to do is write limit of f of x as x goes to infinity. And for this, you're going to want to use the end behavior, so use 4. And then the limit of f of x when x goes to negative infinity, again, is also equal to 4. And then for the domain, in this, you're going to want to use your vertical asymptote, both of your vertical asymptotes. Usually you would use the x-coordinate for the whole, but we don't have that in this case. So you write negative infinity, comma, negative 1, then write u. And for now, you're going to want to write negative 1, comma 1, and you're going to put the negative 1 first since it's a smaller number. And you write the u again, and then use positive 1, comma, infinity. Then for the range, you want to use the y-intercepts and horizontal asymptote. So you're going to do negative infinity, comma, negative 3, then a u, and 4, comma, infinity. So now we're ready to graph, so you want to draw a dashed line vertically through negative 1 and 1, and a dashed line horizontally through the 4. And we only have one point, which is 0, negative 3, so we're going to create a table so we can find some extra points. So you're going to use the x coordinates that you want and plug it into this equation. So we can use negative 2, 2, negative 3, and 3. And it's going to end up equaling 6.3, 6.3, 4.9, and 4.9 again. So now we can just graph that over here, and here. And now you just want to draw a line. So you want to draw the arrow going up because we know it's going like this, and down, and over time it's going to go towards a horizontal asymptote. Same thing over here. And then for this, just point it down since there's nothing you can really go through over here. And then this is my booster.